Good morning to all of you. I am Dr. Neetu Gehlot from SaitmB Institute of Technology and Management, Gurgaon. I am the Applied Science faculty here. Today's my topics are the van der Waals interactions, equation of real gas, and the critical phenomena. Now come to my topic. First topic is the van der Waals interactions. So, first of all, we should know that what is van der Waals forces. So it is well known that the molecule in a solid are the held close together by attractive force. The magnitude of these force decreases as we pass from solid to liquid and from liquid to gaseous phase. So that the intermolecular cohesive forces operated between the molecules which causes a neutral molecule of a covalent compound to condense into the liquid or solid and collectively known as the van der Waals force. These four are the significant only when the molecules are the close together. So that we know that van der Waals force is a very weak force. So first of all, we should know that what are the weak force and what are the strong forces of attraction. Here, as we see that there are the two types of the interactions. First is the strong interaction and the second is the weak interaction. So some bonding interactions are the strong interaction, just like the ionic bond and the covalent bond. These two types of the bonding are the strong interactions bond. And the another that the weak interaction. So as we know that the van der Waals interaction is a very weak interaction, and the hydrogen bonding is also the weak interaction. So, in which type of the molecules have the van der Waals equation? So, as we know that the two non-polar molecule have the van der Waals interaction, two polar molecule have the van der Waals interaction, one polar, one non-polar molecule has van der Waals interaction, the ionic polar, ion, non-polar, these all type of the molecules have the van der Waals interaction. So today, uh, we study that there are the five type of interactions, but three are the most important. But now we discuss about the five type of the interactions, van der Waals interaction. These the name of these type of interactions are the first is the ion dipole interaction, second dipole dipole interaction, then third is the ion induced dipole interaction, fourth is the dipole induced dipole interaction, and fifth is the instantaneous dipole induced dipole interaction. So we discuss one by one all type of the interactions. First is the ion dipole interaction. As the name suggested, that one part is the ion and the another part is the dipole. Dipole means that means there is a polar molecule. So polar means which has the two both positive and the negative. So that the ion means it may be cation or the anion. So if we take the example of the Cl, so Cl is a cation. So that Cl negative, the interaction between the Cl negative and the dipole. Dipole means that is a polar that we take the example of the HCl. So here in the HCl, so here the sharing of the electrons. So one part, so the effect of the due to the effect of the chloride Cl negative, the electron are goes to the Cl this side, so that Cl has the partially negative charge and the H has a partially positive charge. So that chloride has the negative charge and the H has the partially positive charge. So there is an interaction between the ion and the dipole molecule. So this type of interaction is called the ion dipole interaction. Another example of this type is the NaCl also. Second type of interaction is the dipole dipole interaction. So here we take the two molecules, those are the dipole, or we can say those are the polar molecule. So example HCl, here the two molecules of the HCl is interacted together and they are for the effect of the Cl negative. The effect of the Cl negative, this H and the Cl has a partially positive and the partially negative charge here. So that here due to the effect of the Cl negative and the H positive, there is an interaction between the two molecules of the HCl, and this type of interaction is called the dipole-dipole interaction. Now come to the third type of interaction, which is ion-induced dipole interaction. Here, as the name suggested, that the one part is the ionic part. It may be chloride, bromide. So when we take the example of the Br negative, and the second part is the induced dipole. Induced dipole means there is a non-polar molecule, just like the O2, N2, Cl2. So these all the non-polar molecules, and these non-polar molecules is converted into the polar molecules. So this is called the induced dipole, and the interaction between the ion and the induced dipole. So here the example of the Br negative and the H2 molecule. So the bonding between the two electrons between the hydrogen H2 molecule. So that due to the effect of the Br negative, one H has the partially positive and the second is the partially negative charge. So that this type of interaction is called the induced dipole interaction. Now come to the fourth type of the interaction, that is a dipole induced dipole interaction. Dipole induced dipole interaction. So one thing is the dipole and the another molecule is the induced dipole. So as we discussed above, that the which is called the induced dipole, it means there is a non-polar molecule and they convert into the induced molecule due to by the effect the dipole molecule. So that the example, the first is a dipolar. Dipolar means a polar compound, and they take the example of the HCl, and the non-polar molecule is the H2, Cl2, N2. They may be converted into the non-polar molecule. So if we take the example of the Cl2, so here the Cl2 as a that is the sharing of the electron, and due to the effect of the Cl negative for HCl, it has the Cl has the one Cl has the partially positive and the another has the partially negative charges. So this type of interaction is called the induced, sorry, dipole induced dipole interaction. Now the next type of the interaction is called the instantaneous dipole induced dipole interaction. First is the instantaneous dipole induced dipole interaction means कि here both part are the non-polar. First part is instantaneous dipole, second is the induced dipole. We know that the induced dipole means there is a non-polar, or that may be Cl2 and 2 and H2, and the instantaneous dipole means कि if we see the hydrogen molecule or other non-polar molecule in the 3D structure, 3D dimensional, so that we saw that the in case of hydrogen there are the only two electrons here. So these two electrons are moving into the cells or glass, and for a few second, or we can say that is a for a instantaneous time, these electrons are come to the same side. So when these electrons are come to the same side, so it has the negative charge, and same thing that the other side has a positive charge here. So this molecule is work as a instantaneous dipole molecule, and the another part is the induced dipole interaction. Induced dipole, so that the non-polar here again the H2 is the has the electrons. So due to the effect of these positive charge, the electrons come to the effect of the electronic effect, the negative charge, it comes to this side. So that positive charge has interact to the negative charge, and electron goes to the another side. So instantaneous dipole induced dipole interaction means the two non-polar molecules interact together for some time. So this type of interaction is called the London force also. There is the name of the scientist is the London. So that this according to so that this force is called London force, or another name of this type of force is the dispersion force. So now we know that the all type of the interactions of the van der Waals interactions for the interactions of the strong and the weak. Interaction with strong interactions means ionic or the covalent bond, and the van der Waals and the hydrogen bonding are the weak interactions. So these are the five types of the interactions. One is the ion dipole interaction, dipole dipole interaction, ion induced dipole interaction, dipole induced dipole interaction, and instantaneous dipole is induced dipole interaction also. Now I come to my another topic, that is the ideal and the real gas. or deviation from the ideal gas behavior. As we know that every gas has a real gas, which what gases, as we know that the carbon dioxide, oxygen, so, all types of the gases are the real gas. But if the ideal gas means if the gas follow the Boyle's law, Charles law, or other gases law, so these gases comes in the series of the ideal gas equation, ideal gas. So in the ideal gas, here is the equation of the ideal gas, which is called the ideal gas equation, is equal to PV is equal to nRT. Here P is the pressure, V is the volume, N stands for the number of the moles, R for the gas constant, and T for the temperature. So such behavior is stated as ideal or perfect. The modified equation is obtained by the gas equation is equal to, that is the example PV is equal to nRT by applying the correction or the volume and the pressure. So when ideal gas equation, it means that PV is equal to nRT. Here is the theory work that this is called the, according to the kinetic theory, kinetic molecular theory. We know if we study the kinetic molecular theory, so we remember that there are the two main points here. One point is that the volume of gas molecule is lesser than the gas volume, and the another point is that if there is no attraction and repulsion among the gaseous molecules. I read again that the first point is the volume of the gas molecule is lesser than the gas volume, and the number of there is a no attraction or the repulsion among the gaseous molecules. But at this situation is at the lower pressure and the high temperature, and so that we can neglect the volume of the gas molecules and for the gaseous molecules. गैस मॉलिक्यूल टोटल गैस के मॉलिक्यूल के सामने हम लोग गैस के मॉलिक्यूल का एक मॉलिक्यूल के वॉल्यूम को निगलेक्ट कर सकते हैं और देयर जब टेम्परेचर ज़्यादा है, हाई टेम्परेचर है, लो प्रेशर है, सो there is the no attraction or the repulsion between the gaseous molecules. So these 2 points are the very important point of the kinetic molecular theory. But when the gas does not follow these two rules, it means कि we can the number of the molecules will be increased in the piston. So the we cannot neglect the volume of the gas molecules um, in comparison to the gas volume, and when the number of molecules will be increased here, so that there is attraction, the repulsion is also takes place at the low temperature and the high pressure. That does not follow the this behavior. So now what we do, if at that condition there is for the ideal gasification there is requirement of the some correction, or this correction may be the correction of the for the volume and the correction for the pressure. So here we know that suppose the volume is occupied by a gas molecule is V. When the volume of moving molecule, when the molecule is moving, so their effective volume is 4 times than the actual volume. The volume is 4 times than the actual volume, that is the 4V. So let us call B, that is B is equal to 4V. Thus the free volume available to the gas molecule for movement, so that is the corrected volume, or we say that the corrected volume is equal to V minus V for 1 mole, and for the N molecule, N moles, so V minus NP. So this is the correction and the volume, or we can say that if we reduce the volume and the correction in the pressure, so that a molecule which is lying in between the vessel is attracted equally, while the molecule near the wall is attracted by the molecules inside. एक मॉलिक्यूल जो अंदर है वेसल के अंदर, तो वो टेम्परेचर इंक्रीज होने पर उनकी एनर्जी इंक्रीज होगी at this condition, molecule goes to the wall of the vessel. So पीछे वाले molecule है वो उसको खींचने की कोशिश करते हैं. So here we require the high pressure here, so that the molecule which is laying in between the vessel is attracted equally, while the molecule near the wall is attracted by the molecule inside. So hence the pressure will increase. How much? So corrected pressure is the if is corrected pressure is the P plus P. So where small p is proportional to its density square and p is proportional to d square. So that d is inversely proportional to the volume for one molecule, and the inversely for n molecules is proportional inversely proportional to the n molecule of volume. So that we find that the corrected pressure is the P plus A upon V square, or P plus A n square upon V square. So has a real gas equation, or we can say that is the van der Waals equation, is P plus A n square upon V square, V minus Nv is equal to nRT. In this equation, gaseous equation, P stands for the pressure, V for the volume, A and B are the gas constant. They can vary to gas, and then the number of moles, and here N is the number of gaseous molecules, and R is the gas constant, and T for the temperature. So that we can reach the van der Waals equation from the ideal gas equation. Our next topic is the critical phenomena. What is the critical phenomena, or how can we represent it? So we can represent the they are the critical phenomena. Uh, that is the represented by the critical temperature, is the critical temperature, critical pressure at the critical volume. So here the question arises ki how can the gas can be liquefied? How can we convert the gas into the liquid state? So that the answer is we can liquefy the gas into two ways. First is by lowering the temperature, or second is the increasing pressure. These two methods, as we know that the lowering the temperature or by the increasing the pressure, so that the molecule of a gas lie far apart from one another and are in the continuous random motion. As the temperature of the gas is lower, the kinetic energy of the gas molecule also decreases. Okay. As a result of this, some of the molecules get closer to one another, and ultimately the gas change into the liquid state. I explain these the critical temperature for each gas. There exists a certain temperature above which it is impossible to liquefy it, no matter how great the pressure is applied. हम कितना भी pressure apply कर दें उस temperature के बाद हम gas को आप उसको liquefied नहीं कर सकते. So that temperature is called the critical temperature, and it is denoted by the Tc. Now come to the critical pressure. What is critical pressure? The pressure required to liquefy a gas at the critical temperature is called the critical pressure, and it is denoted by the Pc. Now come to the critical volume. The volume occupied by 1 mole of a gas. It is carefully we should remember that the volume occupied by 1 mole of a gas at critical pressure and the temperature, that is called the critical volume, and it is noted by the Vc. So here these are the critical phenomena. So scientist Sir Thomas Andrews in 1861 were the first to study the these critical phenomena experimentally. They used the carbon dioxide gas. Now come to this graph. He take the isotherm condition of carbon dioxide. Isotherm is there the temperature will be constant here. So that there is a graph between the pressure and the volume. At first of all, he took the temperature is 50 degrees centigrade. So at 50 degrees centigrade temperature, when we increase the pressure, when we applying the pressure, he saw that there is a no change in the gases conditions. Okay, so gas found is on at this temperature at the liquid gaseous condition. That means carbon dioxide is found in the gaseous conditions at the 50 degrees centigrade. So that this is the isotherm. And when now he reduce the pressure, now we come to the temperature. Sorry, it reduce the temperature, and now we come to the temperature at the 35.5 degrees centigrade. So he saw Again, he saw that there is a no change in the condition of the gas or state of the gas. As according to the previous, as firstly that he saw that the gas was found in the gaseous condition. So the another time he again saw that the carbon dioxide is found in the gaseous condition. Uh, now come to the he reduce now again he reduce the temperature, that is 31.1 degrees centigrade. At the 31.1 degrees centigrade, when he constant the temperature and increase the pressure, so that when he increased the pressure, he saw that there is some changes, like some molecules of the gas is converted into the liquid, very small molecules is converted into the liquid, and not exact the 31 point degree centigrade. It is the below 0.02 degrees centigrade of at the 31.1. So that this temperature is called the 31.98, and the this is vary to the different books. Some books has referred to the 31.1 is a critical temperature, and the some area the 30.98. The exact value is the 30.98. Now, at this temperature, at the reach to this temperature, we notice that the some molecules of the gas will be converted into the liquid state. But when we increase the pressure again, so that there is a no change in the condition of the gaseous state. So now he does not stop their experiment, and he go at the 21 degree centigrade temperature. At the 21 degree centigrade, now you see that when he apply the pressure at the 21 degree centigrade, so there are the uh, some molecules are converted into the liquid. Now the number of molecules will be increases here for some time, and increasing the pressure. After that, they cannot change the liquid state. They saw that the molecule that does not change the liquid state, but he he cannot stop our experiment, and he goes to the 13.5 degrees centigrade or 30 degrees centigrade temperature also. So that now he see that again he reduced the pressure, so he saw that the molecules number of molecules will be increased. As we see simply, as we saw that the if we have a gas in the container of the gas, and apply the piston is here, and we apply the pressure, so the some molecules are converted into the liquid condition. But after that, maybe few molecules of the gas is converted into liquid, and we applying the pressure is also here, so that some more molecules which are not active in the active form presented, so that they are also activate, and the number of molecules will be increased, which convert into liquid state. So that he saw that now there's the formation of a plateau. This is the plateau form in the 13 degrees centigrade, 21 degrees centigrade, and 31.5 degrees centigrade also. So he noticed that at a 30.98 degrees centigrade temperature is a critical temperature or critical point at which the uh, pressure is the 72.9 atmosphere. This 72.9 atmospheric pressure is called the critical pressure, and the volume for the 1 mole of carbon dioxide is 95.65 ml. So these three values are called the critical phenomena. First is the critical temperature, which is 31.1 degrees centigrade, or some books refer to the 30.98 degrees centigrade. The critical pressure is the 72.9 atmosphere, and the critical volume is the 95.65 ml of the oxygen. So here, at the temperature below 31.31 degrees centigrade, that is the 30.98, carbon dioxide acts sometimes like the ideal gas even at the rather high pressure. Below 31 degrees centigrade, at attempt to the compress the pressure gas to a small volume, even actually gas conditions causes condensation to begin. Thus, at 21 degree, at the pressure of about 62 atmosphere, the volume can be reduced from the 200 centimeter cube to about 55 centimeter cube without any further rise in the pressure. Instead of the gas being compressed, it is replaced with a far more compact liquid, as the gas in essentially being squeezed into this its liquid phase. After all the gas has disappeared in the pressurized and the gas converted into the liquid condition at this temperature, pressure and the volume also. So these phenomena is called the critical pressure, critical volume and the critical temperature. So now I repeat some topics. First of all, we have to discuss about the van der Waals force. Then we come to the types of the van der Waals force. They may be five types: the ionic type, ion dipole dipole interaction, ion induced dipole interaction, dipole induced dipole interaction, and the instantaneous dipole induced dipole interaction also. So we know that the van der Waals force is a very weak interaction, and the some strong interaction is are the ionic bonding and the covalent bonding. Next, we come to the point that the ideal gas or the real gas equation of the ideal gas or the real gas. There the deviation from the ideal gas behavior. So in this topic, we've discussed about the ideal gas equation of kinetic molecular theory, bonds, and the van der Waals equation. How to come to the van der Waals equation from the ideal gas equation. So the points are the correction of the volume and the correction of the pressure. In this point, so we reduce the volume and we increase the pressure here, so that we come to the van der Waals equation. That van der Waals equation is the P plus A n square upon V square, V minus NB is equal to nRT. So this is the correction gas equation, or we can say that is the new equation name is the van der Waals equation. Now the next topic is of this lecture is the critical phenomena, or we can say that the how can we convert the gas into the liquid state. So the answer is that the lower by the lowering the temperature or by the increasing the pressure. These two methods we can convert the gas into the liquid state. So these are the critical phenomena. The critical temperature. What is the critical temperature? As we know, that a certain temperature above which it is impossible to liquefy it, no matter how great the pressure is applied. So this temperature is critical pressure at the critical temperature. At the critical temperature, which pressure is work as that is the critical pressure, and the one for the 1 mole of the gas at the critical temperature and the critical pressure. This is called the critical volume also. Who was a scientist? The Thomas Andrews was the first that in 1861 they explained the critical phenomena by using the carbon dioxide gas. Then the critical point, these critical point means critical temperature, critical pressure, critical volume. The values of these are the critical phenomena, and so that we can explain about all topics. Now I give some questions that explain the critical phenomena for the carbon dioxide gas with the graph. And my second question is the write the what is the van der Waals interaction and explain the all type of the van der Waals equation in detail. So that I complete my lecture. And if you have any doubt, then you can discuss with me. First of all, you refer to my notes and then discuss with me. Thank you.